To sum up all of our lectures about passive transport, I'm going to talk about this very last type of just passive transport. Remember, passive transport, the cell does not supply any energy. These particles are flowing down their concentration gradients, whether it's simple ions or if it's water in the case of diffusion and osmosis respectively. Now this very last one is going to be facilitated diffusion. Since I've got diffusion in here, you already know the gist of what's going to happen, but facilitated means I have to have a little bit of extra help. So this is a very unique type of diffusion. Just like osmosis is the diffusion of water across a membrane, this is another very specific type of diffusion. Basics of this is that protein channels, and remember these are located in that cell membrane, you have them in amongst the phospholipids that make up the bilayer of cell membranes. And they can act as channels, tunnels, pores, receptors. They have many, many different jobs. In the case of facilitated diffusion, I call them channels. So protein channels in the cell membrane that help, that's my key word for here, that help specific molecules to pass. Usually these molecules right here, usually they're too big to just diffuse through. One thing you need to know about the protein channels that make all this up, that operate, that allow for facilitated diffusion, they are very specific. Typically, they only allow one type of molecule to pass. An example of this, red blood cell membranes have specific protein channels to allow glucose, and that's your C6H12O6, so a pretty big molecule, to pass. Without this, your cells, your red blood cells, wouldn't get the nourishment that they need. It would take a lot more effort to get glucose into the cell. So instead of having to use energy, red blood cells have developed a way to use protein channels that will allow for this specific type of diffusion that is still diffusion. It's just helped along with it. It doesn't use any energy. It doesn't have any input from the cell, energy input, but it has to be helped or otherwise it wouldn't occur. So even though the cell membrane is helping with diffusion, there is no energy input. The cell is not putting anything towards this. The molecules still flow down their concentration gradients. They still go from an area of high concentration to an area of low concentration. They still flow down that concentration gradient. It's just they're either too big or in some cases too charged, and they gotta have a little bit of help getting across. They can't just flow like simple diffusion or osmosis. They need a little bit extra help. I put in a picture to help kind of explain this. If you look at this, on the outside of the cell, pretend this is that glucose, and I'm looking at the cell membrane of a red blood cell. Glucose is still going to flow down that concentration gradient, and it's going to be intercepted by that protein channel, and then it basically just flows through it. But it has to have the help of that protein channel. It can't just diffuse through like water and like other simple compounds like calcium or potassium or sodium, simple ions like that. Glucose is way too big. Remember, it's C6H12O6, so way, way, way too big. This concludes this lecture. Very short and sweet, and I will see you in class.